In this problem, we have an antenna on top of a building. From a location 275 feet from the base of the building, the angle of elevation to the top of the building is measured to be 38 degrees. From that same location, the angle of elevation to the top of the antenna is measured to be 41 degrees. Find the height of the antenna. All right, let's draw a diagram. Here's the ground. Okay, we have a tall building here. And on top of this building, we have an antenna. I'm going to make the antenna red. Okay, now we have someone way out here who's looking up at this, okay? Now, the angle of elevation to the top of the building is this angle right here, which is 38 degrees. And we can assume that this is a right angle over here. Now the angle of elevation to the top of the antenna is 41 degrees, and I barely have room to draw that in. That's that full angle right there. Actually, let's do that in a different color here. So that angle right there is 41 degrees. Okay, so we have two separate right triangles going on. Now, we know that the base of the building is 275 feet away from the person. So this side right here is 275. That's the distance from here to this person here. And we do not know the height of the building. The goal is to find the height of the antenna. So let's call this distance right here A for antenna. Now what we have are two separate right triangles, and it's a little difficult to work with them because they're drawn on top of each other. So to make this a little bit simpler, I'm going to draw these triangles out separately. So here's the smaller one. This is the 38-degree angle. And in order to solve this problem, we're going to need to somehow represent the height of the building. So let's call this distance B for building here, which we do not know. And then our other angle, triangle that is, the bigger one has the 41-degree angle of elevation right here. Also has a side of 275, and this distance, that's the distance from the ground all the way to the top of the antenna, so that distance is actually A plus B. So this is A plus B right here. Now we can use right triangle trigonometry to set up a ratio for each of these triangles, and then we can solve for, ultimately we can solve for A. So let's start with this simpler triangle that just has the B. So we want to use a trig ratio that relates the opposite side to the adjacent side of a right triangle. That trig ratio is tangent. So we can say that tangent of 38 degrees is equal to B, the opposite side of that angle, over 275, the adjacent side of that triangle. And we can solve this directly for B. So B is equal to 275 times tangent of 38 degrees. And we are going to have to approximate that on a calculator. So we're going to have tangent of 38 degrees. So we'll do 38. Take the tangent, and we're going to multiply that times 275 to get 214 point. Let's see, ultimately we're going to answer to 3 decimals, so let's carry this out to 5 to be way on the safe side here. So 214.85354. Okay. So that's what we got from the first triangle. Now, we can do the same thing with this second triangle. And we also need to use tangent here because for this angle 41 degrees, we want to solve for this unknown side, A plus B. That's the opposite side of the angle, and we are given the adjacent side of the angle. So we can say tangent of 41 degrees is equal to the opposite, A plus B, over the adjacent, 275. We can multiply by 275 times tangent of 41 degrees there. Oops. Is equal to A plus B, and then of course we can plug in B here and also approximate this number on a calculator. So I'm going to start by approximating 275 times tangent of 41 degrees. So let's go with 41, take tangent of that, multiply times 275 to get 239.05385. And that's equal to A plus B. B is this number 214.85354, and we can solve that for A by subtracting. So if we compute this number minus the 214.85354, we get 24.200 rounded to 3 decimal places. And that's it for this problem.